Right, let's look at some interesting ideas around gradients as they relate to parallel and perpendicular lines. First of all, there's a line going through these 2 points. Can you calculate for me the gradient of this line? We could use rise over run. So the rise here is 4, the run is 2. 4 divided by 2 gives me 2. I could do it that way. I could use my gradient formula that says the gradient is y2 minus y1 over x2 minus x1, using these as my x1 and y1, x2 and y2 values. And if I plugged them in or substitute them into that formula, I would get a value of 2, which is encouraging because that's what I worked out using the rise over run method as well. So the gradient is 2. Here's another line that is parallel to my first line. So let's call this line 2. I know it's parallel because it has the parallel marks on it. Can I work out the gradient of this line? Well, yeah, I can. I could take 2 points, any 2 points, and I can say, well, the rise is 2, the run is 1, 2 over 1 gives me 2, or I could use the formula, just like we did in the first instance, and I would calculate my gradient to equal 2. What do you notice about the 2 gradients? Yeah, of course, they are the same. So that's the first important idea for us, is that parallel lines have the same gradient. In other words, m of 1 will equal m of 2. So if 2 lines have the same gradient, we know that they are parallel. What about if I took a line that was not parallel, that was the opposite of parallel, and that is perpendicular? In other words, it crosses at 90 degrees. So we call that perpendicular. Let's take the gradient, or calculate the gradient of that. Once again, I could use my rise over run. My rise is 2, my run is 4. So 2 over 4 is the same as a half. It's going to be negative because it's sloping up to the left. So I'd say that the gradient is negative a half. Now I could check using the formula by plugging in those values. Okay, taking the values of these 2 points, okay, and put them into my formula, I would get a value of negative a half. Once again, that's great because that's exactly what I worked out using the rise over run method. Excellent. So we know that the gradient of this line is negative a half. This is the same line from the first part of the video, so the gradient of that one is 2. Now, if I multiply these 2 gradients together, I get a value of negative 1. 2 times negative a half gives me negative 1. That is our first important point to note. If 2 lines are perpendicular, the product of their gradients is negative 1. In other words, when I multiply them together, I will always get negative 1. So 2 gradients, if they multiply together to give me negative 1, I know that those lines are perpendicular. Another way of saying this involves this idea of a negative reciprocal. So in other words, the gradients of perpendicular lines are what we call negative reciprocals of each other. So let me explain that. Gradient of the first line we said was 2. If I write that as a fraction, 2 can be written as 2 over 1. Now the reciprocal is simply where you take a fraction and turn it upside down. So if I did that, my reciprocal fraction would be 1/2. The negative reciprocal would be negative of that. So in other words, the negative reciprocal of 2 is negative a half. And that's exactly what we had up here. These 2 numbers, these 2 gradients, we can see are actually negative reciprocals of each other. If I started with a negative half and went the other way, still works. So if I had a gradient of negative half, let's have a look at what the negative reciprocal is. First thing I do is I turn that upside down. So now I have negative 2 over 1. But I need to take the negative of that value. So 2 negatives, so I've now added this other negative in front of it, give a positive, in this case, positive 2. So the negative reciprocal of negative 1/2 is 2. And you can see that in this case, that works. My lines are perpendicular, so the gradients are in fact negative reciprocals of each other, and when I multiply them together, I've got a value of negative 1.